Hello everyone. Today we are having a 23rd Grad Talk, and we are having our guest from Atlanta, Georgia, Barış Tiryaki'ye, industrial engineer. Now this time I will not make an introduction. I guess in the slides he will introduce himself. So hello Barış, how is that? I guess it's early in the morning in Atlanta, right?
Yes, it's 9 a.m. here. It's coffee time, so I'm just
Okay.
Good
morning to Atlanta.
Good afternoon to you guys.
So, okay, you may start. We are with you, Barış. Thank you.
Well, thank you, Murat. Hey everyone. Good afternoon to you all. Before I start, I would like to say thank you for having me in this forum. Right. So it's I know that you guys have amazing line of speakers every month. Really advanced topics. So what I'm about to cover today is not advanced at all, but I would like to first of all thank you. It's really an honor and a privilege for me to be here with you as a speaker. So with that, I would like to start off with, with our kind of topic today is basically, the data analytics trends for, IT professionals. I thought this would be a good topic for, newly graduate or undergrad students who may want to kind of consider data analytics as potential fields of domain as they look to work opportunities in the future. So with that, I would like to start off a little bit about myself. If I can switch the slide, and give you kind of my context and background a little bit. Yes, was there a question? Sorry. Okay. So I'm an industrial engineer. I graduated back in 96 to be exact, from Bilkent University. And right after that, I did my MBA in Istanbul. And I started my career in Turkey back then when SAP, if you're familiar with it, I'm sure some of you are, was just getting the visibility and getting kind of more and more SAP implementations in the industry, right? So my start of career just coincided with the start of maybe some SAP implementations in Turkey, and being an industrial engineer, that seemed to be a good fit for me to get my career started. And it was really good because it gives you the perspective in terms of understanding the business processes and how to configure and implement, a tool like SAP, which gives you, a lot of possibilities, a lot of configuration options to really try to bridge the gap between, what you see in the business process and how you implement this in ERP implementations and ERP systems. So that I worked maybe till year 2004. And I decided to move to US at that point. Firstly, I just wanted to get some experience, some work experience in US, right, to improve my English, as well as get some experience, the working experience in US. And the original plan was to stay here maybe for 3-4 years, but it turned out a bit differently for me. So I've been still here after, I guess, 18 years at this point. So throughout this 18 years, I worked for, 3 or 4 major Fortune 500 companies. So when I started, when I did the first, I would say 10 years, I done a lot of, continuation of how I started with SAP, right? So it's still with the SAP implementations, taking up roles like business analyst and functional experts. And my focus of my focus with SAP was mostly finance and controlling, and a little bit about sales and distribution as well. And slowly, and year maybe 2012, roughly 10 years ago, I picked an interest with data. So I wanted to learn, how we kind of move the data between ERP systems into data warehouses, how you build reports and dashboards. The basic concepts about the business intelligence really attracted me. And a few years after that, the topic of big data just became, it just literally exploded, right? So everybody was talking about big data, the cloud transformations. So at that point, I really wanted to make a switch and change my focus a little bit from ERP implementations into, doing in the field of data analytics. So that's probably the last 6-7 years of my career has been exclusively on data topics, right? Data and analytics. So in between, I have also played roles like enterprise architecture, which is very interesting when you think about, the companies doing their digital transformation. It's always data and analytics becomes the center of attention. As the companies tries to monetize, the data into value basically, and getting closer to their customers and using data analytics in the meantime. So I played the enterprise architect role for a number of years. And in my current role, I am the data analytics leader and in this global storage and tool manufacturer, Stanley, Decker. So this is a bit about myself and my background. Again, a lot of SAP in my past, ERP experience, being an industrial engineer, I guess this is a natural trend, and then switch into data analytics a bit later in my career. So with that, I would like to transition to the topic of my speech today. If I can change the slide, okay. So obviously the area of data analytics has a lot of depth and breadth, right? So, and I'm not going to go into all that advanced topics that you have around feature engineering, data science, machine learning, and special topics. But I will just try to give my high-level view from an IT technology standpoint, right? I would like to go down to the basics, and I would like to first look at what is analytics. When we say analytics, everyone seems to have their kind of own opinion. So let's kind of boil it down and let's simplify, let's understand what it is, right? At the end of the day, analytics is nothing but the process of extracting actionable insights from the data, right? So it always starts with a business problem. You always have plenty of problems, right? Plenty of use cases or business problems. And once you formulate your problem, once you kind of take it into a more, a kind of like a mathematically oriented theory, right? Then you go look after your data. You go get your data, whether internal, external data sources everywhere, right? So from data, you use analytics methods to drive some insight. And then maybe the insight will tell you, well, here is the reasons for your customers changing, from your brand to some other brand, right? And after you find that insight out, you have to take it in an action. You have to take some action because otherwise it's meaningless, right? So why did you have to do all that work and find a good insight if you're not going to make it action at the end? And that's the whole, this value framework, really. It's starting from the business problem, getting into some sort of action to be able to get the value at the end, to be able to monetize, right? So let's go back to business problems because this is really the most exciting part for me, right? So a lot of the rest of it is, yes, very technical. Part of it is technical, but it's really the variety of the business problems here is really amazing, right? And especially recently with, and I'll talk about this in our further slides, with the more recent trends in the data analytics technology, the amount of problems, the nature of business problems that you can answer become exploded basically, right? So, I mean, let's look at some of use cases, right? So if you're a consumer product good company, you probably would like to know, how your margins are trending for your major customers compared to last year, right? How is your competitor doing against yourself? And if you're curious about why are customers switching to competitive brands, there's your internal data and there's the external market data that you can go after to kind of try to find the drivers, right? If you're a manufacturer, let's say you're an automaker or you're an agricultural machinery maker, and you have very high warranty claims, you would like to understand what's driving this warranty claims. Is that the quality of your products? Is that the customer service? Or is it something else that's kind of leading up to it, right? So, and these decisions, these insights always needs to be data-driven, right? So far without the data-driven, it's more gut feel approach, right? So you have a theory, you think that it's because of this or that, and the actions, when they are not necessarily based on data, may not lead into kind of most predictable or most desirable outcomes, right? So again, to me, the most exciting part of the analytics is the depth and the breadth of the problems that you can work on, right? So it's not just always, well, I'm going to report my margin data. No, in a company, there's perhaps hundreds of business problems and use cases where you can employ data analytics to try to get insight. So again, going back to basics, analytics, the process of extracting actionable insights from the data and taking an action at the end. If any part of this chain is broken, obviously you won't be able to get the value from analytics at the end. Yeah. So I just thought that this would be important to highlight. And when you look at the maturity curve, when we talk about data analytics, right, up until I would say around year 2000, maybe 2010, we were mostly in the descriptive analytics space, right? So it's more about, we get the data, the raw data, maybe clean the data, maybe we have some standard reports, and this is kind of very traditional, let's say, data warehousing, right? So from maybe 80s going into 2000, 2010, it has been heavily on, okay, you have your data in your ERP systems or source systems. Let's build up this dedicated data warehouses, which are really powerful, but they are monolithic systems, right? So the moment you want to scale, you need to kind of get more expensive infrastructure to be able to get the scale that you're looking for, right? So that's, but the type of problem you address with that has been typically very descriptive, meaning that you look at the past, right? So you're looking at, okay, what was my sales compared to this month compared to 3 months before, right? So the last quarter. So you don't necessarily look at problems that requires a bit more advanced solutions, right? So for instance, deploying some machine learning models to be able to find out, okay, what if my customers who tends to buy this product, seems to also buy that product. That kind of questions did not get answered in the descriptive analytics. It was more looking in the past. Well, not what changed around year 2008, 2010, depending on who you talk to, right? So there was a cloud transformation, and there was an explosion of data, and with that it comes the distributed computing, which I will talk in the next slides, but that enabled the business users or the business community to start doing more predictive analytics on top of what they have done so far with the descriptive analytics, right? So traditionally it required a lot of computation powers and more advanced hardware to be able to deploy prescriptive analytics and predictive analytics. And when I say predictive analytics, it's basically let's think about your demand forecasting, right? So you have the history of demand for the last 36 months and other drivers that may impact the demand. Now you build a predictive model that tells you what's going to be your demand in the next 6 months, right? So that's predictive analytics in the very typical definition. Not that it didn't exist in the past, obviously it did, but the scale of what's possible became much bigger, right? And the prescriptive analytics is basically the end of the maturity, where you have autonomous systems, which not only does the predictive analytics in terms of predicting what's going to come next, but takes an action. For instance, it may be an automated business decision. You have an automated rule that says, well, if my demand forecast goes like that, and there's an automated workflow that triggers some business action. Yeah. So that's kind of like the maturity, and the fully autonomous systems obviously are at the top end of this maturity curve. But really, the value goes exponentially higher when you move from prescriptive into predictive from descriptive into predictive into prescriptive. Yeah. So this is about the maturity of analytics going back from 80s. So let's go to the next slide and talk about a little bit about the analytics framework, right? So again, we talked about a great depth and breadth of data analytics in general. Yeah, so it has a lot of components, right? So this has technical foundations and it has business foundations. And none of this will happen if any of these pieces are missing, right? So it goes from data to insight and insights to action in the framework. Now, under the technical pillars, you have your data sources, right? You have to deal with, you know, the variety and diversity of the new data sources that grows exponentially every day, right? You need to know how to clean, enrich, and wrangle all that data, because the data is almost every time is not in a good state, right? So you have to be able to wrangle, you have to be able to clean it up, you have to be able to enrich and blend and merge to be able to make it meaningful. Now then comes your analytics tool set, right? So you have the software, tools, and analytics methods, and the talent who can take that data, who can then, you know, make that data, turn that data into some actionable insight. And that takes a lot, right? So that takes a lot of expertise in the softwares and the programming languages, in understanding of the mathematical methods when it comes to statistics, statistical analysis, or machine learning models. So that's really a very, very key area, right? So that's very much in demand. Now, on the IT infrastructure, you know, obviously you do need to have the right infrastructure set up, right? So with cloud computing, cloud storage, and distributed computing, this stuff really becomes very feasible, right? So the things that tends to be extremely expensive in the past because there was no cloud, so you have to buy expensive hardware yourself to be able to really facilitate this kind of advanced analytics. Now it's really, because it's really simple, because now you have the cloud providers giving you really elastic services that enables you to kind of start with something small and scale as you need, right? So it becomes a lot more you know, feasible and easy to really to get into that space, not like you have to wait for $1 million server to arrive 6 months after you order so you can start doing something. No, you can really get going really fast. Now, in that space, obviously, the programming languages, your Python, SQLs, R's, and that kind of things, and general software programming skills and CI/CD principles, continuous improvement, continuous development, right? So there's a lot of version control, code deployment, automated testing, that all goes into that technical construct. And there's, you know, a lot of tools and a lot of, I guess, skill set that really just fits into that space. Now, under the business foundation, you have the people who we call the critical skill set, we call the translators, who has the domain knowledge, right? So remember, we talk about the business problems, you know, everything starts with the business problems. Well, you have to have people who are really familiar with their line of business, their line of functional or domain area, to be able to formulate this problem. Hey, we have a problem because we have, you know, we can't forecast our demand well, or we don't know why our warranty spend is trending this high, or we have an issue with a certain, you know, set of customers, for whatever reasons, they are not paying on time. So let's figure out why, right? So that requires that kind of, even coming up with the formulation of that questions requires some domain knowledge. So you need people with translator skills. And then the translators can take that problem and turn it into a mathematical model that they can work with, let's say, IT-minded individuals, right? So maybe the data scientists, to be able to formulate that problem so that you can come up with a more you know, fully functional use case. Now you know what data to go after, you know the hypothesis, the test, and things of that nature. Once you know the insight, the other role that people play there is, once the insight has been unlocked by the data analytics, then you have to turn that into an action, right? Obviously, this won't just happen by itself. So you need the functional people there who could, you know, translate those actions into some, you know, decisions and some actions within their line of business, right? So if you see a customer margin has not improved, maybe, well, you may want to think about doing something, right? So either increase your price or maybe stop having that customer. So some action needs to be taken. So the people will always play a big role. And on the process, you know, once you build these analytical capabilities, you may want to integrate that with your business workflows, right? So you have some insights coming continuously. Maybe you would like to automate your process so that it triggers certain actions at the end automatically without you having to do something, right? So that's the whole, really, the framework that has its technical and the business foundations and the pillars. And this is all for, obviously, analytics strategy cannot be thought separately from the business strategy. So the business strategy and business vision drives the analytics strategy, drives all the business use cases, and the operating model that surrounds it with the right security model, the data governance, and data, preventing data silos, the security and privacy concerns. Those are the kind of things that you have to have, right? Regardless, so that's kind of under the operating model. So I'm moving on. If there's any questions, actually, feel free to just, come in and ask. I don't have too many slides, so but I will keep going. So next, I would like to kind of take a look at the high-level architecture, right? So of any generic analytics platform, and especially with the coming of the cloud providers, I think this is important. I actually played the role of an enterprise architect for 5 years for an agriculture machinery maker. So this was all I do. I used to create diagrams and obviously understand the technologies too. But I think this is really important, especially if you are new in the field, to understand, okay, what's happening here, right? So when you go from left to right, so on your left, and this is typical architecture, right? On your left, you have an amazing, I guess, variety of data sources. And most typically, you have your ERP systems that has wealth of data, right? So you have your products, customers, invoices, orders, purchase orders, receipts, manufacturing orders, everything is there, right? So for the most part, and that's typically SAP, JD Edwards, Oracle, whatever ERP you use, your kind of core of your business is there. You have you may have separate CRM, customer relationship management systems, which is very important for especially companies taking on more digital ways, right? So getting closer to their end consumers and having more targeted advertising and targeted opportunities. So that all lives in their CRM systems. And Salesforce is this kind of, I guess, the leading CRM platform of the time. You may have an e-commerce channel. You may where you have your clickstream data, your sales transactions, and you may have like a dealer portal, a customer portal. I mean, you name it, right? So any given multinational may have hundreds of applications. I'm not exaggerating, because they have a lot of legacy systems. They don't necessarily use one tool for everything. Depending on the geography, they may be using different tools. So the amount of data sources is really crazy high. On top of your internal data we discussed so far, there's also a wealth of external data sources that's available, right? So these are anything from your market share, your competitive intelligence. So there are companies out there selling data, right? So there's POS data if you are a manufacturer, and if you only go indirect, so you have no idea, what your products are selling between your indirect and your direct customers, right? So there's POS data you can buy, which will give you more insights. And the companies obviously do buy this data to really understand, okay, how is my real sales trending? How can I, maybe optimize my inventory levels, that kind of things, right? But, again, on the left, variety of data sources that's getting richer and richer every day. Now, on the big box in the middle is basically your cloud analytics platform, right? So the big box over here. And generally speaking, your cloud providers are AWS, Google Cloud Platform, or Microsoft Azure, right? So what happens within this cloud platform is you typically have, you bring your data from your source systems into your, what we call different zones, right? So you have the raw zone, where the data comes exactly as it was in the source, right? So that's why it kind of mirrors whatever is in the source. And this is good because you don't have to worry about filtering any data. You don't have to bring it only in parts and pieces, because within the new cloud framework, data storage is extremely cheap. So you don't have to, you don't have to worry about, oh, did I bring too much data? It's going to cost me too much money. No, really, the storage is generally the least part of the cost equation in the whole world of analytics. So the best practice is to bring everything you have, so you don't have to, if there's a use case in the future that may require you to look at the data differently, you don't have to go back all the way to your ERP systems or CRM systems to change your ETL and bring more data. No, everything's here in the raw zone, right? Once the data is in the raw zone, you use data transformation tools to cleanse them and bring them into a good format that's more agreeable to kind of building more, more analytics capabilities, right? And at the end, you go from the standardized zone into curated zone. Curated means it's clean, it's trusted, it's ready for business. So you can put this in front of your business people to start getting value, right? So, and this is really where the world of data engineers lives. All that works within the cloud that requires you transforming the data, massaging the data, cleaning the data, and linking and enriching the data will require a lot of what we call data engineering skill set, right? And we will talk about different skill sets in the world of data, but typically you have the data engineers and data analysts and data scientists and data visualization experts. I think those are very common roles in the world of data, I would say. There may be more, but this is typically kind of how I see it, right? So on the very right, once you prepare your data, the data is in curated zone, it's ready for business, so to speak. All that data preparation, wrangling happen using data engineering techniques and all that plenty of tools that you have inside the cloud, which we'll talk in a second. The next step is obviously analysis and exploration. And it really takes two forms, right? So it's generally and more traditionally, it's BI and reporting. So at the end of the day, you bring your ERP data and it's you curated it, it's nicely linked and everything. So you would like to have some maybe Tableau or Power BI dashboards that gives you visibility into your margins, into your daily sales, into your whatever it may be, right? So, and very traditionally, very often, maybe 90% of the time, that's where your end goal is. You would like to have a data visualization that tells you how is your sales trending, how are your margins going, that kind of thing. Well, more recently, we also see this advanced analytics, AI, ML, right? So it's more, if you need this data for not only building some reporting and dashboard, but you want to go a step further to build a model that predicts something, right? So maybe you have, you're a telecommunication company and you know that your customers are switching between the providers, right? So you want to bring all your features into your data, maybe the age of the customer, the profile, the demographics, and his past buying trends, whatever information you have about the customer, and see, from the past data, you would like to understand, okay, what has been driving them to switch between the providers, right? So this is the topic of advanced analytics, AI and ML. The nice thing is that this cloud framework, AWS, Google Cloud, and Azure, all of them, right? So have plenty of tools for you to kind of do all this, both data visualization and advanced analytics in one, tool set, rather than you having to use, part on-prem infrastructure and part cloud, right? So they have actually matured quite a lot since they started about 10 years ago, and they have plenty of services for you to kind of use without, again, exporting your data and having to do things, outside their systems. So this is the high-level overview of the architecture, which I find helpful. And so let's talk a little bit about the recent trends. I'm watching the time here. We talk about the cloud platforms, right? So this is really what changed the game, right? Because with cloud, you have now and virtually, unlimited scalability. And this is really was in the past, this was unthinkable, right? So in the past paradigm, you had a data center and you used to buy infrastructure if you need a new server because you need some new data warehousing need, or you have some new data needs. And those are really expensive, let's say IBM servers, right? So you wait for 6 months for it to arrive, you set it up, you configure it. It's a lot of overhead. It's very expensive. It becomes, it makes the barrier to entry very high. But with the cloud paradigm, that changed totally, right? So now this, cloud providers gives you basically infinite scalability. You can start it with pretty much nothing. It may cost in the beginning a couple of dollars, literally, right? So depending on, of course, what you're trying to do. So it may go a bit more than that. But the point here is that your barrier to entry goes away. So it kind of democratizes the data and data advanced analytics for everyone, right? So increased scalability is the key. Elasticity, it means really your infrastructure can scale up and down as you wish. And the concept of horizontal scaling, again, in the past, the scaling had been vertical, right? So if you want to have more data warehousing, you need to buy a bigger, better servers, which becomes exponentially more expensive. Now you have this commodity hardware. You may have hundreds of, servers, small servers or computers that can do the compute task for you instead of one giant server who you may need occasionally, but the rest of the time it's just sitting idle, but you're still paying for it regardless, right? So this reduces the overhead and barrier to entry. Reduced overhead is also important. You don't need a server administrator every time to be able to keep that server kind of healthy and running properly, right? So the serverless infrastructure that also eliminates overhead. So what I mean by that is that now cloud providers gives you options to have this, let's say, data warehouses or databases that are virtually, requires no overhead on your part. So you just load your data and you kind of hook up and extract your data. There's no database administration. You don't need anyone to be babysitting it, so to speak, right? So in the past paradigm, you need dedicated people to be able to keep them kind of running properly. And the paradigm around the separation of compute and the storage resources is also important. You no longer have to perform your compute and the storage on the same infrastructure. So that also is another factor that gives you the scale and the cost reduction. So there's a lot of native services for building automated data pipelines and ML models. Remember I said this, these cloud providers have matured in their data capabilities. Now they have a lot of services. I mean, when you look at AWS and Amazon Web Services, right? There was around, this is like an old information now, 160 different services it provides. And one of them is called AWS Glue, right? With AWS Glue, you can, connect to your data source and you can transform it using Spark and Python or SQL, whichever language you want, right? So you just bring in your own code. You don't worry about all the computational needs that you would need, all the servers that you may need. It just provides it and it charges you whatever, however many minutes you use for it, right? So it's really becomes quite simple. And more and more there's auto ML services, and this is really interesting because if you are a data scientist, you probably know and understand about the mathematical models, deep statistical models, right? So, but more and more, this service is becoming so smart that you just plug in your data, and the system determines, what mathematical model, what machine learning model to apply. Whether there's, regression analysis, logistic regression, clustering model. Let the cloud figure that out for you. You plug in your data, and it runs a whole bunch of things, and it tells you, here's the best model that we find, right? So in a way, it's making it easy for everyone, not only for data scientists, to be able to do more advanced, machine learning analysis. Yeah. All right. So talk about the programming languages and frameworks. I just want to highlight some big ones, right? So obviously SQL is still the king in the world of data. Python is an amazing programming language. I'm not a technical programmer myself, but I try to learn Python, and it's really very fun. And the reason what makes Python different in my mind is because it has these libraries called NumPy and Pandas that makes it extremely easy for a non-starter to transform the data, right? So you can, anything that you do on Excel, simple operations or more advanced operations, you can do it with code and you can scale it. Once the beauty with the code is once you know how to code these, now you can import it in the cloud and you can do it with a much larger scale. And that's really what programming languages like Python gives you. Now the Spark has also gained a lot of attention because it's not a programming, it's a distributed framework, right? So it makes your programs like Python programs to be distributed across, many different computers, so to speak, so that it can just run independently and then bring back the result much faster, right? So the processes that runs hours in the past now can finish much sooner and much, again, cost-effective and cheaper, right? We talk a little bit about CI/CD pipelines, version controls, and DevOps, right? So these are also kind of important, I guess, technical skills to have in the world of data analytics. Yeah. I'm going quick a little bit, data scientists. I'm not going to stay too much on this, but what are the key roles on data analytics domain, right? So you always talk about the role of a data scientist, which is probably the coolest of the roles, right? So it's always in between the fields of computer science, math and statistics, and business and domain expertise. So a proper data science needs to bring these three in a blended way, so you can understand the business domain and the use cases, right? So explores the data, look at the correlations, and formulates the business problems, and come up with some hypotheses to test. And then it determines, okay, what mathematical model to apply for this particular problem, right? And then, once you do that, you figure out what data that you need. You work with data engineers to be able to bring that data into the best format you're going to need. And at the end, you build and deploy these machine learning models, typically using, Python, R on your cloud infrastructure, right? So the second key role, and this is probably the most important role, because overall the process of analytics is really extremely heavy with data wrangling, right? And so that data engineer plays the key role here, right? So a data engineer is the person who understands how to kind of ingest the data from its source into your data platform, which is typically on the cloud, and who can transform and blend and merge the data to make it ready and curated for your business. And there's a lot that goes into that space, like, because you need to be able to kind of understand the data requirement, extract the data from the source system, go through all that many transformation and data cleansing steps. They should know how to leverage the cloud infrastructure for scalable and automated data pipeline build, right? And they are the folks who are, very heavy on SQL, Python, Spark, and understanding the cloud infrastructure in general and how to make use of it. And lastly, as a key kind of domain expert, I would say is, and this is probably a very good starting point for a lot of people, is data visualization experts, right? So at the end of the day, for the most part, majority of data analytics ends with a dashboard, right? So this is the end game. So the data visualization experts are the folks who know how to kind of make a story from the data. So it's more of an art than a science, really, at this point, because these are the people who knows how to present the data, so that the business users, when you look at it with a one screen look, they understand what's happening in the business. And obviously it's a bit more than that, but they work with the business to map business requirements into dashboards. They build wireframes and mockups for kind of figuring out what's the most effective data visualization. Right, so they use storytelling to bring this insight to the business users, and they leverage tools like Tableau, Power BI, and ClickView. These are perhaps the top three in the industry at the moment. But generally speaking, this is really a good starting point if you would like to learn data, because they are not very complex. You know how to build some charts and graphs and visualizations using these tools like Tableau and Power BI, which are very much in great demand at the moment. So Murat, I'm just flying through some of these a little bit, but let me know if you want me to slow down, or if there's any questions. I'm also happy to take. For now, I'm going. I guess this is my last slide. So, and we can kind of go into.
Yeah, we have plenty of time. Take your time, okay?
Okay, so we can take some time for Q&A later on. So, okay. So the last slide here I put together, I wanted to kind of compile some, let's say, my recommendations for aspiring data practitioners, right? So if you are interested in, in the field of data analytics, which I highly recommend, right? So this has been my passion perhaps for the last 8-9 years, and I did not regret it, right? So I did not regret from switching my focus from SAP into data analytics. And as far as I see, it remains very hot at the moment, very much in demand. And to be honest, there's not enough talent out there, right? So you see the companies here in the US, they are hiring just new starters because, again, they are very much in demand. Not only just the big, cool technology companies like Apple's and Facebook's and then the others, but the mainstream companies are also very much in this, right? So they don't want to be behind the curve. They want to be out there getting, getting the value of their data, right? So with that, I kind of put together some thoughts here. It's not complete by any means, but this is kind of what worked for me, right? So, and I wanted to share that with you. So if your aspiration is to maybe one day becoming a data scientist, maybe make sure that you have a solid math and statistic foundation, right? Like I studied industrial engineer. I really enjoyed the deep statistical and stochastic concepts back in the day, but that has been very long time ago, right? So yes, I still have the foundation, but one needs to always refresh himself to make sure that you know about these different machine learning models, which one to deploy when, right? So that's really, that would really come very useful in terms of understanding all that machine learning models, so you know that what kind of business problems, what kind of models you can kind of marry with. Yeah. So learning programming language, the second one, Python. I can't say more about Python. Really, if you have time, just don't waste it. Try to learn Python, right? There's amazing level of resources there, the free resources. If you want to do paid, sure, do it too. But it's really, even just in YouTube, right? Just forget about anywhere else. The amount of free stuff available for Python or cloud is just mind-boggling, right? So maybe 15 years ago, if you were new to SAP and if you want to learn SAP, good luck, right? So you have to go to an extensive training to get a certification, but that changed completely now, right? So you really have no excuse at the moment to kind of learn this stuff, right? The SQL still is important language. SQL is important. Make sure you know the basics. You don't have to go crazy. It's really simple, right? Learn about Spark. If you want to be a data engineer one day, which is, again, in extreme high demand, right? Learn about Spark and the distributed computing, right? Because this is an extremely valuable skill set for the cloud and cloud infrastructure. This is how you're going to achieve the scale in the cloud platforms, right? So if you're a data engineer, make sure you learn not only Python, but Spark. So you understand how to get the compute load gets distributed into different compute resources. Understand cloud platforms basics, right? So tools offer set for data analytics. Now, I was lucky enough in my previous company that they went with AWS, right? So it was kind of new for them too. So, and I was always curious, right? I wasn't deep technical myself, but I wanted to kind of talk with the developers to understand it a bit better, right? So I can do some basic stuff. And when I was in between jobs for 4 months, I was like, I'm going to get deeper with this stuff, right? So I took some time. I actually took maybe 3-4 months. I said, well, I'm going to learn this. I'm going to get the certification for AWS, which was difficult, right? So it's really almost like a full-time job for 2-3 months. A lot of learnings, but great stuff. It really wouldn't be boring at all if you have a passion in this space. And I was able to get my certification. And if I can get it as a relatively non-technical people, believe me, you can too. There's, again, amazing level of training materials on the websites of like AWS, Microsoft, and Google Cloud Compute, platform, all free. They don't hide anything away from you. And their motivation as well is better for them, right? The more people know their cloud platform, the better. They will get more usage and more money. So the old paradigm has shifted. So they make everything available, right? And even getting the certification wasn't that expensive. It was $100 or something like that. So it wasn't really, it is well worth it for your future when you think about it. I put some resources like YouTube channels with AWS reInvent. That's the yearly event that they have, which gets a lot of attraction. You can sign up for their free tier accounts and experiment yourself, right? So you don't have to kind of go big. You can start with something small. You may have some, there's a lot of like samples, great samples in places like GitHub, where you can kind of get started and then start playing around with the data yourself in the cloud. That's a great way to learn the cloud, right? There's also online learning platforms. I used some of them in the past. like Coursera, Data Camp, Udemy. Those tends to be the kind of like the large ones, right? So they're quite popular. And those are also great, but again, you don't have to. Everything is really pretty much readily available in between this cloud websites and any other kind of open websites, including YouTube, obviously, right? Pursue cloud certification, especially in the United States. They are very highly recognized at this point and valued in the industry, right? So it gives you an opportunity to also specialize in different fields, because cloud is not only for data analytics, obviously, it's for general needs, but the data analytics capabilities within the cloud has been kind of growing, and that has been a kind of focal point for a lot of companies. So if you pursue certification, there's even chances to specialize only in data analytics. This is what I did, right? So you see that this thing is valued when you're hearing back from the companies when you apply to positions. And lastly, if you would like to kind of do data visualization as a starter, which is also a very good idea in my mind, right? So if you don't want to go through the programming Spark and all that stuff to start with, learning Tableau or Power BI could also be a great way to get started with things. Connect to your data is already ready somewhere, come up with the right visualization and figure out how to tell a story, come up with dashboards and KPIs that may be, high impact to your business users. So those are really good areas to get started. So, I mean, overall, these are my recommendation. I think, if you are, I don't know, if you're like me, right? So I studied industrial engineering, not that it's limited to industrial engineers, don't get me wrong, but I think there is this field of data analytics within information technology, right? So there's probably two fields at the moment that has been very hot. One is the information security, right? The other one is data analytics, and it has been like that for the last maybe 5-6 years now, and I don't see this dying down anytime soon. Especially the cloud, with the cloud experts at the moment, they're again very much in demand, and at this point you cannot really separate data analytics from the cloud anyway. So you have to kind of converse in both languages to be a kind of top talent in this domain and the field. So I think this is all I have, Murat and Nazir, for today. It's around maybe 10 minutes. We have 10 more minutes left, I see. Maybe we can.
Thank you very much, Barış.
Yeah.
Yes, if we have questions and comments, now we can take the questions and comments. And also, Ömer will send you an inquiry. Küçük bir anket linki gönderecek, katılımcılarımız yapabilirler. Okay, we can take the questions if you have any. You may either raise your hand. Now you see the inquiry.
Yes.
Okay.
I do. Mm-hmm. Yeah.
And we can take the questions. You may raise your hands or you may use the chat box. For myself, I'm a little curious about the data. I'm also using the data in different fields. I'm doing the modeling in high energy physics. So what we have is basically we have the data, cleaning the raw data, cleaning the data, and by using a model, we are predicting something. So prediction comes with an error, right? So a couple of weeks ago, we talked about the construction projects, and they use a model, and if you have a delay in your $1 million projects, a construction project, even like a week or a 1 month delay cost you a lot. So they define the delay and the responsibility of the shareholders so that they share the cost of that delay, kind of. And it comes with the sharp number, like 15 days of delay. It's a prediction. So I was just wondering, your type of predictive zone, you say your descriptive part and predictive part, do you have those kind of error bars or you have sharp numbers?
No, I mean, I think typically speaking, Murat, is generally your predictive model comes with some guardrails, right? So you would say, I'm 80% sure, I'm 90% sure that this customer will switch if I do nothing within the next 6 months. So it never comes with a perfect certainty, right? So there's always some error range in the error interval. And I guess the machine learning models is a game of, okay, how accurate you want to become versus there's a trade-off, right? So there's a trade-off you do need to play. When you tune your parameters, I guess, when building the machine learning models, there's always a trade-off between, you know, how accurate you want to become, you want this to be versus the amount of data you have, or again, I'm not a data scientist myself, but there's always no certainty, right? So in these things, it's always kind of margin of error you have to deal with. Yeah.
Thank you. Do we have any question and comments?
While may I ask a question before?
Nezir Hocam, he is himself also industrial engineer. Okay, go ahead, Nezir.
Yeah, industrial engineer. Thank you very much for this nice presentation. As Dr. Murat said, also I'm an industrial engineer, and we were not, when I was student, we weren't familiar with those terms like machine learning, like even computer programming. Like we didn't take, I can say maybe 1 or 2. So now we have those kind of courses in our programs. However, we are still not that familiar with them, and the guideline you show us, the programs that we should learn or we should be curious about, they will be helpful for us. My question is actually, you know, we create our predictive models and we predict the future based on data that we already have.
Yeah.
However, future is not that certain. Sure. It brings us different uncertainties. So is there a way to include those kind of uncertainties that we haven't experienced before in our models?
Yeah, I mean, that becomes difficult, right? Because generally speaking, you build the models based on the data that you have and based on the features that you think, right? So if your demand is impacted by weather, by competitors, by your past sales, and, you know, many other factors, right? So maybe you build your, you know, machine learning model to use those features to predict into the future, right? So that's all great. But if you have some unaccounted development, let's say political or a new war is happening, right? Then your model has never seen it in the past, so it doesn't know, you know, how to deal with it, right? So therefore, it's never perfect, right? So there's going to be always some new features that's going to come in, or maybe you haven't necessarily included in your model. Therefore, it doesn't know about it, and it produces, you know, it cannot predict the future all that well. So I guess it's all, you know, the continuous improvement as you have more and more data, as you learn more from the, you know, what's really the driving factors behind, let's say, demand in this case, right? Then you can fine tune and make your model better. I mean, the example that I gave for the warranty span, right? So you have a very high warranty span. Why is that, right? So is that because your quality is bad, or something happened in your production line on that date? You know, maybe the screws were getting very tight, stuff like that, right? So or it was your customer service, or was it you're kind of making your customer sad because of something else, right? All that factors, then whatever you can find, you make it your features to be able to predict whether the customer is going to claim a next warranty or not, right? So and if you haven't factored in, I mean, some other potential factors, right? That you maybe you haven't initially considered, yeah, you're not going to get a great result. Therefore, it's always a kind of like an agile learning curve, right? So hopefully, if you're doing it the right way, you don't get everything figured out perfectly in the first attempt, but it gets better and better over time. Yeah.
Thank you. Actually, I have a quick, short question too. Like, sure. You said most of the time the data is not that clean. You need to clean it, and you spend lots of time on that.
Yes.
I'm curious about, can we pass that duty to computers? Like, is there any algorithm or like tool that
No.
can do that for us? Doesn't matter what the data is, but is there anything like that?
Not really. I mean, the computers will help you with the scale, but you still need to define the rules of the game, right? So you have to say, well, I want this field to be in this format, right? If it wasn't in that format, make sure that you build the rules to bring it in that format, right? So there's data preparation and cleansing is the, maybe 90% literally of the overall time you spend on that, right? And so far, the systems, I guess, are not smart enough for you to know, okay, how do you really want the data at the end, and figure out what it needs to take, what it takes to be able to get the data in that format just by themselves, right? So that hasn't happened yet. Well, maybe with future development, we may see that happening too, right? But for now, they are more manual. You need to program them. You need to build those rules. So it gives you the computation scale and everything, but you still have to tell the system, like, here's what I want to do. So change that format into this way, right? So make it, if there's a dirty data that came in, ignore it or delete the whole line or whatever. So you have to define those rules for it to be able to function properly. Yeah. So we are not there yet in terms of the.
Hopefully in the future. Thank you.
Great questions. Thank you.
Do we have any more questions and comments?
And,
I guess.
There is one in the chat, Dr. Murat.
Yeah, I mean, you can ask in Turkish too, guys. Don't be shy. So it's not.
Clinton would like to ask a question. If you have a microphone, Clinton, you may ask for yourself. Let me. Ömer, do you manage the Clinton?
Clinton.
Yes, go ahead.
I don't have clearly a question, but I would like to thank our presenter today for the presentation.
Okay.
Because
you express your appreciations, I guess. You do not have a question, right?
Yes, I'm just very thankful.
Thank you, Clinton.
Scan in the chat boxes. We have many thanks. So if you don't have any, yes, Clinton, do you want to say something? No, okay.
No. I was going to just jump in and say, I put my email and LinkedIn information. Please feel free to connect with me. I'll be happy to be in touch. And if there's questions later on, or if we want advice, as much as possible, I'll try to help you. Right, if there's any interest later on, so I put it here.
Thank you very much, Barış. And on my university behalf, I would like to thank you to our guest speaker today, Barış Tiryaki'ye from Atlanta, Georgia, for sharing all his experience from the field and real life data. I would like to thank also all attendees. Yasemin Hocam, buyurun.
Sadece yazmıştım ama sanırım görülmedi. Sadece güvenliği açısından çok teşekkürler Barış Bey. Ben sadece data güvenliği açısından, buluttaki bilgilerin güvenliği açısından da bir şeyler söylenebilir mi diye bir soru göndermiştim ama.
Tabii, istiyorsanız biraz Türkçe'ye de geçebiliriz.
Buyurun.
Yani eğer kötü konuşursam belki İngilizce'ye switch etmek zorunda kalabilirim ama
İsterseniz İngilizce de söyleyebilirsiniz. Ben zaten soruyu İngilizce göndermiştim. Siz bilirsiniz.
Kusura bakmayın hocam, kaçırmışım.
Estağfurullah, önemli değil.
Let me do it in English because I may be using weird terminology otherwise, right? So the data security and privacy is extremely important. Remember, I said there's two fields that are very much in demand today. One is data analytics for sure. The other one is information security. Information security is just, you can't imagine how crazy important it is, right? So, and I don't care for myself all that much, but I see the companies, the amount of focus that they put in protecting the data, the right encryption, the right privacy measures, right security models, and all that comes with it is becoming more and more of a concern, right? So as you have more data vulnerabilities, the attacks coming from, the external parties, the companies have been investing heavily in their data security. And on the data privacy front, you heard about this European law, right? GDPR. Some of you might have heard. So it becomes extremely important for you to be able to store the data only in certain places where these new regulations mandate, and to be able to kind of have the right encryption and protection built onto it to make sure you don't get any unauthorized access, right? So in the European countries, and the GDPR is especially very sensitive to people having access into private information, like your social security number, your name, your address, that kind of like your customers' information. Obviously, it becomes extremely difficult sometimes to really be able to protect them in the cloud with bringing the right security and encryption measures. But yeah, there's a lot on that domain just by itself. It's just a field of, I guess, specialization by itself, I would say. Yeah.
Thank you. Teşekkür
Thank
ederim.
you.
Sağ olun.
Teşekkürler
Hocam,
Barış.
Emine Akpınar söz
Emine
almak.
çok kısa alalım. Diğer bir toplantıya yetişeceğiz biz de. Emine sendeyiz hızlıca.
Hocam biraz uzun ama tamam,
Kısa.
kısa bir şekilde sadece hocaya şunu sormak istiyorum hocam. İstersen İngilizce sorabilirim ama İngilizce sorayım. Thank you for your presentation, sir. My question is about the data augmentation. So when there is not enough data, the augmentation is done to train artificial intelligence. For example, GAN's method is used to reproduce MR images. So I want to learn how accurate do you think the data augmentation in health data is? It is right to use this artificial intelligence model in hospitals?
That's a great question, Emine, and thank you for that. But I don't think I have enough depth in that area to be able to give you a kind of good answer. Yeah? So I don't know much about the data augmentation specifically, but maybe I can inquire if you don't mind, maybe dropping me a note with my email. I'll kind of try to do a bit of research to come back to you.
Okay, thank you.
Thank you. Great question.
Thank you everyone. Again, thank you Barış. Çok teşekkürler for this nice presentation. Okay, we wish you a nice day in Georgia early in the morning.
Again, it's been an honor and a privilege to be here with you. Really enjoyed it, and thank you for having me, Murat. And
thank you, and see you everyone on next week at the same time for the next Grad Talk. Thank you. Bye.
Bye everyone. Have a great rest of the day.
Herkese iyi akşamlar. Teşekkürler.